Consider another example that is also quite representative of externalities, but that is more complicated to solve. Now we have a market in which all externalities are firm to firm. And in particular, the story that we have in mind is that each unit of production, each unit of Q that is produced creates 1 unit of pollution E. So notice that this implies that the externality, the total level of externality, is equal to total production. The J's are firms. Okay? Now, we're going to assume that the demand function is given for the market by 1000 minus P, that there are 10 identical firms, just for the purpose of this example, and they have each a cost function C of Q of J equals to 5 Q squared of J plus E Q J. Again, when E is the total level of the externality, or total level of the pollution in the market. So think of an example in which, as the firms produce, they create pollution, but that makes it harder and harder to produce. They impose cost, or they increase the marginal cost of production for other firms. Notice that the marginal cost increases because here the marginal cost of Qj given E is 10 Qj plus E. So every unit produced by any firm increases the total level of the total marginal cost for every firm by 1 unit. Now let's derive the supply function by looking at the problem of a typical firm. So each firm is going to have the following problem. Maximize over Q greater or equal than 0 is revenue PQ minus its costs, which are 5Q squared plus EQ. Critical, as before, this level of externality is taken as given when solving the problem. Why? Because there are many players at the firm assumes that it cannot affect the total level of pollution. This is of course not literally true, but it's a good approximation, and when there are enough players, it's a very, very good approximation of how the firms behave. Now, this implies this is going to have a solution in which the marginal revenue is equal to P, the marginal cost is going to 10Q plus E, and this implies that the supply of any firm J is going to be P minus E divided by 10, and the supply of the market, which is just 10 times that, is just P minus E. Okay? Now, important, in equilibrium, that E is going to be equals to Q star. But when we have derived the problem of the firm, we have assumed that the firms were taking that as given. We have not, the firms were not really worrying about how their own actions were affecting this. Notice that this problem, the reason that this problem is more complicated than the previous one, is that now the behavior of the consumer or of the firm, in this particular case the firm, depends on the level of the externality. Before, it was independent. Now, what's the market equilibrium? We know as before that in equilibrium it's going to have to be the case that the quantity demanded in the market is equal to the quantity supplied in the market, and that prices are going to adjust so that that happens. But there is another thing here that we have to worry, which is that the total level of the externality is going to be equal to the total level that is sold by the firms. So both equations are going to be true in equilibrium. Okay? Now let's work with the second equation first. We know that in equilibrium, so we have derived before that the market supply as a function of P is equal to P minus E. But that implies that since in equilibrium E has to be equals to the Q of the market, this implies, doing the algebra, you just substitute and do the algebra, that the quantity supplied by the market is just P divided by 2. Now, substituting in 1, this implies that the demand in the market, which is 1000 minus P, has to be equal to the supply in the market, taking into account the effect of the externality in the demand. It gives you P over 2, and this implies doing the algebra that P star is equal to 2000 over 3, and that Q star is equal to 1000 over 3 units. Okay. Notice the key thing was here that we had to take into account to really pin down the supply function that whatever quantity was done in equilibrium, that was going to affect the amount supply through the externality. Now, we know that the optimal quantity is going to be given by the intersection of the marginal social benefit equals to the marginal social cost. We saw that in different ways over the previous units, and especially on the previous video lecture. The key thing in any externalities problem is to characterize properly what the marginal social benefit and the marginal social cost curve are. So let's do that. The marginal social benefit in this particular example is just the marginal private benefit because the consumers are not being affected by the externality. And we know that the marginal private benefit is just what we have been calling the aggregate marginal benefit function before, which is just the equal also to the inverse demand for the market, which is going to be therefore equal to just 1000 minus Q. Okay? The only new change of reasoning here, chain of reasoning, has been this, that because there are no externalities, the marginal social benefit equal to the marginal private benefit. What about the marginal social cost? See, when it's a little bit more complicated in this problem, but if you use a little bit of economic intuition and logic that I hope you have started to really internalize, it's actually not that hard. Now, what is going to be the marginal social cost is the cost of increasing production by a tiny amount. Now, notice that the individual production functions, cost functions for the firms are C of Qj equals 5Q squared plus EQ. This increases non-linearly, therefore, with Q. And this implies that it is optimal to split production equally across firms. In other words, you want to give every firm an equal share to really minimize the cost of production by avoiding the quadratic term to kick in. That implies that total social cost times 1 by TSC is equal to 10, because there are 10 firms, of producing Q units, times the cost for each firm of producing, let me rewrite this to improve the notation, times the cost of producing 10 units in a typical firm, and this is equal to 10 times 5 Q squared over 100 plus the externality is going to be the total level produced, so Q times Q over 10. Notice again, don't be confused here, this terms is equal to the externality. This is equal to 3/2 of Q squared. And therefore, if you take the derivative with respect to Q, we get that the marginal social cost is just 3Q. What you should learn from this is that if you are not sure how to compute the marginal social cost, in the case in which there are externalities in production, what you can do is compute what is the optimal way of setting up production, set up the total social cost, and take the derivative. So what is the optimal quantity, therefore? We have marginal social benefit equals marginal social cost, which implies 1000 minus Q equals 3Q, which implies that Q optimal has to be equal to 250. To gain more intuition, it's useful to look at the difference between marginal private cost and marginal social cost in further detail, and these are different. Now, we have seen that marginal social cost is 3Q. We just derived that. The question is, what's marginal private cost? Well, we know that marginal private cost is going to be equal to what we have been calling the aggregate marginal cost function, which is just equal to the inverse supply function as a function of Q. for the market, and we know that this is just P minus E. Now, importantly, this is not just any, sorry, which we have seen was P plus E, I'm sorry. But that's just not any E, is the E at equilibrium. So I'm going to add star there. And of course, we know that E star is going to be equal to Q star because of the assumptions of the technology for the externality, which is the sum of the quantity produced. Now, we know, therefore, that in equilibrium, this is going to be equal to P plus 1,000 divided by 3, which is the quantity produced. So I'm going to plot for you what these animals look like. Marginal social cost is equal to 3Q. Okay? A function that looks like a marginal private cost, sorry, or the, let me say it differently, the inverse supply function of the market when there are no externalities is just Q. Okay? Apologize, there is a typo here. It should be a Q. It's the inverse. Okay? And finally, we have what's the marginal private cost, which is the cost that the firms are using to base the supply function on. It's just the one without externalities plus this external effect that they internalize, which is just a shift up by E star equals to 1,000 over 3. That is their marginal private cost in equilibrium. Okay? Now, why do I call it equilibrium? Because the value depends on what they anticipate E to be, and they are assuming that this is fixed at the value in equilibrium. Notice how this is different from the marginal social cost, and it's also shifted from the case of no externalities. Also know that in this example, again, it depends on the equilibrium value of the externality. Now let's put all together in a diagram that is going to allow us to compute the size of the inefficiency. So these are dollars per unit as always. It's a quantity in the market. First, we're going to have this curve, which crosses here at 1,000, has an expression of, is the inverse market demand function, which is 1,000 minus Q. And we know that because all of the externalities are within the production sector, this is equal to the marginal private benefit and the marginal social benefit. We also know that the supply curve in this particular case is going to take the form, so it's a supply curve in the market against in inverse form, to Q plus E star, which is Q plus 1,000 divided by 3. The equilibrium is going to be given by the intersection of these two curves and is at a quantity of 1,000 divided by 3. Notice also that this is equal to the marginal private cost, the cost that the firms are internalizing when they are making the decision about how much to supply. Finally, we have this curve, which is 3Q, which is equal to the marginal social cost. And that gives us this point, which is Q optimum, equals to 250. Now, as before, we find that the optimal level of production is less than the amount generated with the market, which again is a general feature of these markets with public bats. Now, the question, of course, is what is the deadweight loss? Well, which is going to be given by the area between the optimal quantity and the quantity produced between the marginal social cost and the marginal social benefit curve. So by now you should be used to that. It's going to be given by this area. That is the deadweight loss in the market.